Hello, my dear students, and the rest of the learners. Welcome to part 2 of 8 in Fundamentals of Developing a Computer Program, in which we are going to learn about computer programming languages. My name is Member JM, or you can simply call me Emily Swap. In this presentation, we are going to look at the categories and generations of programming languages. Number 2, we are going to look at the various questions that you need to ask yourself when choosing a programming language. And number 3, we are going to look at the factors that you need to consider when choosing a programming language. Let's commence by looking at the categories and generations of programming languages. A programming language is a set of commands, instructions, symbols, and codes that enable a programmer to create a program. Just as humans understand a variety of programming languages or spoken languages, just as humans understand a variety of programming or a variety of spoken languages, such as English, Spanish, French, and so on, computers also recognize a variety of programming languages. Each programming language has its own grammatical or syntax rules, which must be obeyed in order to write a valid program, just as a natural language has its own rules for forming sentences. All the programming languages have evolved through 5 main generations, or what we call GLs, which are the first, the 5th generation. The first and second generations were composed of a low-level programming language or low-level programming languages, while the 3rd to the 5th programming languages were referred to as high-level programming languages. Let's look at what we call the low-level programming languages. These are the primitive programming languages that are directly understood by the computer because they require very little effort or no effort at all to be translated into computer understandable form. A program is said to be low-level when its syntax is closer to the language that the computer itself uses. These programs are hardware-oriented, and thus each program is coded to be used only by a specific computer. The 2 types of low-level programming languages are the machine language and the assembly language. So, what is a machine language? Machine languages formed what we call the 1st generation of programming languages. They are the programs written as a set of instructions that are in the binary form, that is 0 or 1, or what we call machine icons, that does not require to be translated into object code for the computer to understand. A programmer in this context is simply required to write his program or her program in strings of zeros and ones, calculate and allocate the called memory locations for his or her data, and or his instructions or her instructions. It is the only language that the computer can understand because all the instructions and data are in form of binary, thus forming what we call object code. And therefore, the earliest digital electronic computers were programmed directly in binary, typically via punch tickers, the pluggables, or front panel switches. The 2nd generation of programming languages or type is what we call the assembly languages. The assembly languages were also called 2nd generation languages or 2GLs. These are programming languages that were used for writing a set of instructions in form of mnemonics. They are therefore the programming languages in which data elements, operational codes or instructions, and storage locations are represented as a set of symbolic operation codes called mnemonics or shortened 2 or 3 letter ones. The programs written in this language are translated into machine code before execution using a translator that is called an assembler. They were developed to express operations more arbitrarily and reduce the difficulties in writing machine language programs. I repeat that the assembly languages were simply developed to express operations more abstractly and use or reduce the difficulties in writing machine language programs. And for this reason, an assembler translates programs written in assembly language into machine language that the computer can understand and execute. The other category of programming languages is what we call the high-level programming languages. These are programming languages which enable the programmer to develop source code in a language that resembles that of human beings, whereby the syntax and the semantics of the statements does not reflect the internal code of any particular computer. Therefore, a program is said to be coded in a high-level programming language if the language that has been used by the programmer to write the instructions in the source code is closer to the language that humans use by being read and understood by people who are not experts in programming. The source code developed using a high-level programming language. The source code developed using a high-level programming language is machine independent. In other words, it is not built or developed with a specific computer in mind. It is therefore portable. Why? Because it can be run and executed in any family of computers, provided the relevant translator software is installed. They are user-friendly and problem-oriented rather than machine-based. This implies that during a programming session, the programmer concentrates on the problem solving rather than how a machine will operate. A program written in a high-level programming language needs to be translated into machine-readable form by a translator for it to be executed. Therefore, the three generations or categories of high-level programming languages are the third generation programming languages, the fourth generation programming languages, and the fifth generation programming languages. So what are third generation programming languages? These are programming languages that enable a programmer to break down a problem or a program into modules and subroutines or subprograms, thus being flexible, easier to read, and modify. A module is a portion of the main program or groups of processing instructions within the main program that is tailored at performing a particular task using simple control structures in problem solving. Some examples of third-generation programming languages, which sometimes are referred to as structured programming languages, include C, Pascal, Fortran, COBOL, amongst others. What are fourth-generation languages? The fourth-generation programming languages are non-procedural programming languages that frees the programmer from the tedious work of writing lines of code by allowing the programmers to specify the results they want, or the computer determines the sequence of instructions that will accomplish those results. They provide the programmer with controls and application generators to use, thus setting him or her free from spending a lot of time developing the sequence of instructions that the computer must follow to achieve a result. The programmer simply selects graphical objects that are called controls on the screen and then uses them to create designs on a form by dragging a mouse pointer. The controls are graphical objects on the screen that a computer selects and uses them to create designs on a base form. I repeat, controls are graphical objects on the screen that a user selects and uses them to create designs on a base form. The application generator is used to generate the necessary code, hence freeing the programmer from the tedious work of writing the code. These languages are used to inquire and access the data stored in database systems. Hence, they are described as query languages, such as structured query languages, SQL, the report generators, the application generators, decision support languages, and the graphics languages. The fourth generation languages, therefore, fall into the following categories. One is database query languages. In this case, the query languages enable non-programmers to use certain easily understood commands, search and generate reports from a database. They include SQL, or structured query language. Number two are what we call the reporting generators. For example, Oracle report, RPG3, RPG4, that is report program generator 4, report program generator 3. Number three is what we call the data manipulation, analysis, and reporting languages. For example, Focus. Number four are what we call the data stream languages. For example, Iris Explorer. Number five are what we call the screen pointers and generators. For example, Oracle Forms. Number six is what we call the graphical user interface creators or GUI creators. For example, Visual Basic. Number seven is what we call the application generators. These contain a number of modules, logically related program statements that have been programmed to accomplish various tasks. They include Delphi Pascal, Visual COBOL, C++, amongst others. The fifth generation languages, on the other hand, are the programming languages that are designed to make the computer to solve the problem for the programmer by depicting human-like intelligence, thus letting the programmer to only worry of the problem to be solved and the conditions to be met, but not to spend a lot of time coming up with a solution or writing the code. They automatically generate all the code that is needed to solve a problem once the user informs it the problem to be solved and the conditions to be met. They use a visual or graphical development interface to create a program that is usually compiled with a 3GL or with a third generation language or fourth generation programming languages compiler. They are used mainly in artificial intelligence. The programs are concerned with what the result will be rather than how it will be arrived at. Examples of such programming languages are Prolog, Mercury, Lisp, Occam, and OPS5, that is Official Production System 5. So before you decide as to which programming language or which program you are going to use to code your program, what are some of the questions that you must ask yourself? So the questions to ask yourself before you choose a programming language are or include, number one, the project purpose and domain. You need to ask yourself what type of application you are building and what is the objective of the programming language that you need. Number two is performance and efficiency. You need to ask yourself how critical your processing speed will be and the resource utilization for your project. Number three is the time to production. You need to ask yourself what time is needed to be taken to make the program go live when the code is production ready and works as intended. Number four is readability and syntax. Here, you need to ask yourself how easy the language that you are going to choose is to understand and write code in. Number five is community and support. You need to ask yourself how large and active is your language community, which can provide help with troubleshooting and libraries. Number six, you need to focus on the learning curve. Here, You have to find out how easy it is for developers to pick up the language, especially if they are new to it. Number 7 is platform compatibility. You need to ask yourself which operating systems and platforms can the language that you are choosing run on. You also need to ask yourself as to which platform will your program run. Number 8, you need to consider libraries and frameworks. Here, you need to ask yourself whether the language that you're about to choose has a rich ecosystem of libraries and frameworks that can accelerate program development. Number 9 is scalability. Here, you need to ask yourself whether the language or programming language that you are choosing is able to handle growing project needs and large amounts of data. Number 10 is the elasticity of a language. You need to ask yourself how easy it is to add new features into an existing program. Number 11 is security features. You need to ask yourself whether the programming language you are about to choose offer built-in security mechanisms to protect your data against vulnerabilities. Number 12 is maintenance and legacy code. You need to ask yourself how easy it will be to maintain and update the code in the future. Number 13 is team expertise. You need to ask yourself what level of experience your developers have with different programming languages. Number 14 is the cost. You need to ask yourself how much the programming language you are about to choose will cost. Once you have asked yourself those questions, then the following are the factors to consider when choosing a programming language. Number 1 is the availability of the relevant translator. Translators help in converting the source codes or program statements written in any of the computer programming languages to their object codes, or what we call the computer language equivalents. Number 2 is error checking and diagnosis. These factors involve finding the errors in a program and their causes. The programmers should therefore choose programming languages which contain efficient error handling features. Number 3 is the ease of learning and use. The programming language chosen should be the one that is easy for users to learn and use. Number 4 is reliability. Some features are built into some programming languages already to prevent them from crashing. Before choosing a programming language, you should therefore think if or what can happen if your program crashes and how easy it will be to fix it. Number 5 is the purpose of the program. That is the application areas such as education, business, science, etc. Number 6 is the execution time. Applications that require a quick response are best programmed in machine code or assembly language. The high-level languages, on the other hand, are not suitable for such an application because they take longer to be translated and executed. Number 7 is the development time. Development time is the time a programmer takes to write and run a program. The high-level languages are easy to read, understand, and develop, hence they require less development time. The machine code and assembly languages are relatively difficult to read, understand, and develop, hence they are time-consuming. Number 8 is popularity. The language selected should be suitable and or successful in the market concerning the problems to be solved. Number 9 is documentation. It should have accompanying documentation or descriptions on how to use the language or maintain the programs written in the language. Number 10 is maintenance. The programs are developed to solve a specific problem, and the problems keep on changing. For this reason, the programs are also changed to perform the new functions. Program maintenance is therefore the activity of incorporating more routines into the program, modifying the existing routines, or removing the obsolete routines to make the program adapt to a functionality that has enhanced the development. The maintenance is made easier if the language used is easy to read and understand. Number 11 is tool support. You need to consider the hardware that will be required to develop the program and its specifications. The hardware is the equivalent to be used in performing the necessary functions during programming and in the execution of programs. Number 12 is the IDE platform. This is a program that allows you to easily manage large software programs, edit files, compile, link, run, and debug your programs with the use of the respective programs. You therefore need to ask yourself whether the programming language that you want to use to develop your source code contains its own integrated development environment that can allow you to perform all your program's operations, or whether you require another platform to enable you to have an integrated development environment for use. The language with an IDE of well-supported development, debugging, and compilation tools should be selected. Some examples of IDE include Ellipse, NetBeans, Falcon C++, amongst others. And with that, my dear students and the rest of the learners, we have come to the end of part 2 of the series. You can now proceed and listen to part 3 of 8 of the series, in which we are going to learn about computer program development. Congratulations for learning part 2 of 8 on computer programming languages in fundamentals of developing computer program. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on MLSWAP ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading and subscribed. For any further correspondence, kindly write to us through the email mlswap@gmail.com. Thank you very much for listening to me, and God bless.